Hey everyone, today I wanted to tell you guys about a bigger, literally about a bigger um infinity. Yeah, exactly, a bigger infinity. And this type of infinity is named uncountable. Okay, just do that. Yeah, it's named, guys, uncountable infinity, and it's basically the fact that it cannot be counted. This formation, guys, of infinity can never be counted. It's uncountable. Like countable infinity, there is never an ending. You can never reach an end. But uncountable infinity is that you can never even begin, let alone reach an end. You can never begin. And an example of this is how you would count. For example, in countable infinity, you go 1, then you'll put 2 after 1, then you're going to put the number 3 after 1, then the number 4 after 1, then the number 5 after 1, then 6. You just keep going, etc., like that, and you will just never reach an ending. But uncountable infinity, you would never even start. An example of this would be 0, then that's it. Then what's after 0? 0, 0.0. Then what's after that? 0, 0.00. What's after that? 0, 0.000. I have 3 zeros now after the decimal point, and that is really small amount. That's like 10,000 times. Wait, 1,000 times small. Let me just compare. Let's just assume how much that was. Okay, second. Oh, come on, come on, come on. Not that, not that, not that. I meant to. Oh yeah. So 1,000 times smaller than 1 is 0.001. So that's 2 zeros after the decimal point. Now, imagine 4 zeros after the decimal point. That does not matter. We can add 25 zeros after the decimal point. That is 0.00000. Alright, that's 5 zeros after the decimal point. That doesn't matter. We can always add another 0. Always add another 0, guys. Okay? And by the way, guys, look at this shirt. Look. See that? It says Ireland. Because I recently went to Ireland. Yeah, guys, I recently went to Ireland, guys. And you see that shirt? I got this amazing shirt. As my journey to Ireland there. My Ireland journey, guys. I went there, so yeah, that's my shirt. You see that? That's amazing shirt. Yeah, so that's uncountable infinity. We can add another 0 and we'll never get to 1. And that does not even matter. Now, guys, even if, for example, there's one set of infinite zeros, ones, and all that, and there's one set of infinite zeros and there's one set of infinite ones. For example, we can do 0.1111. There's one set of infinite, but there's an infinite set of infinite 0 ones together. And I know there is a way you can stretch them. Like there is a way that you can put an infinite set, infinite lines, infinite set with infinite lines, infinite number of infinite lines together and stretch them out by doing like a zigzag this or something like that. You can stretch them out, and this would probably be the fact that once they are stretched, you can then add them onto one infinitely long line. And for example, any number you can think of, guys, yeah, any number you can think of is a real number. 0.5757 recurring, you name it. 0. Let's say the number 0.010111, and somewhere 10,000, 100,000 ones later on there's a 3, and before it recurs into 1 forever. You name it, exactly that is there. Exactly that number is there. 0. 4040404404444044404, and it keeps recurring like that until somewhere there's a 1, and it keeps recurring like that forever. That's a real number too. You see, anything I can tell you is a real number. Except, let me tell you, we are not going to count numbers such as I, like the negative square root. For example, unless it does mean something that would be considered a real number, unless that is something like a target. Like 1 is the target, 10 is the target, but labeling the different two targets. For example, guys, did you know that you can always, if it had every, imagine guys, there was a 0 point, and then there's 1, 3, 5, any of the 10 digits, because there's only 10 number digits. So there's any of the 10 number digits, and you spread them down. In fact, you can write a new one by doing this method. You get to look at the first digit, then write a number that is not that digit after the decimal point, because there's an infinite digits after the decimal point. Then, after you do that, say the first digit after 0 is 0.1. So you want any number that's different than 1. Yeah. Then you want to go diagonal. So block 1, integer 1. Then block 2, integer 2. A bit like this. Alright, I'm describing it to you now. Okay guys, I don't know how to describe it to you, but look at this. Imagine this is block 1, right there. And there's nothing there. Okay, but yeah, it's block 1, this is 0 and the decimal point, then that's 1. Then, after that is 2. So, what we'll do there is that, if that's a 1, you add anything except a 1. So, a 0, for example, then you go down this way, you go down the corner. And if that's a 1, you can add anything but a 1. Another 1, you can add, for example, say, another 0 there. And then if that's a 3, anything but 3. That's a 5, anything but 5, and just keep going, and so on. So you see that, and that's the term of that kind of thing, for example. Another infinity that cannot be counted, for example, is fractional infinity. And this is actually the same size as, this can be listed as the same as, but I'm going to tell you guys why this type of infinity is uncountable. Let's say we have a 0, yeah. Then we can do 0 over 1, then 0 over 2, then 0 over 3, then 0 over 4, then 0 over 5. When is the point that we are going to get to 1? There is no point. If I keep going that long row, I'll never get to 1 over 0, to 1 over 1. I'll never get to 1 over 1. If I keep going this direction, I'll just add 0 over 10,000. I'll never get to 1 over 1. 0 over 3, I'll never get to 1. And even though 3 is an incomprehensibly large number, it's absolutely incomprehensibly large, it doesn't matter. I am nowhere close, and I'll never even make it to the next column. So that's an uncountable fraction. And there are ways they can be counted by listing them like in sets like this, but never in the directional lines. So you guys, I hope you enjoyed this video, and I'll see you in another one. Bye.